This is project 2.4.1, the Breadboard ATmega328P. The purpose of this project was to introduce the Breadboard ATmega chip and the standalone Arduino and its functions. So for this project, I decided to remake my ISP last year, the analog view meter, and make it digital. I like to break this circuit down into three parts: power, the ATmega328P, and then input and output. Let's start with power. The power for the circuit is fed in through this DC barrel jack at 9 volts and converted down to 5 volts through this 7805 voltage regulator. The next part of the circuit is the ATmega328P. So this part consists of a 16 megahertz crystal, two 22 picofarad capacitors. So this part makes an external oscillating hertz of 16 megahertz. So this is not necessary because you can use the 8 megahertz clock signal inside the chip, but it is recommended. Next, we have the 10 kilo ohm resistor and the push button. This keeps the Arduino from resetting itself. And pins 7, 20, and 21 are connected to 5 volts, and pin 8 and 22 connect to ground. Now that this ATmega328P is on the breadboard, there's no longer USB serial to program the chip like on this Arduino Uno. So there are three new ways of programming it. You can either pull out this chip and put it back on the Arduino, which is the lazy way, and it gets complicated if, say, the chip is embedded in a circuit and or it's hard to reach. The second way is over serial communication by connecting the TX pin and along with the RX pin to pin 2 and reset pin to 1. The last way is to use ICSB or in-circuit programming to form programming in which the microcontroller is programmed serially, meaning that the binary code, 1s and 0s, are sent one at a time to a microcontroller and then executed by the microcontroller. The last part of my circuit is the inputs and outputs. So for the input of my sound is an Adafruit backpack that has an amplifier and then a 10 LED bar graph.